Hello class, today we're going to cover section 2.5, graphs of tangents, cotangents, cosecants, and secant functions. So the first function that we're going to graph is the tangent function. And the one thing that I want you to remember is that tangent of x really is the same as sine of x over cosine of x. And so what's important about that is since it's a fraction, we know that cosine is going to be 0 at certain spots. And so it's 0 at pi over 2, so that means we're going to have a vertical asymptote there. It's also going to be 0 at 3 pi over 2, so there's a vertical asymptote there. And also at negative pi over 2 and negative 3 pi over 2. So we now can see something about tangent. One of the important things is that a period for tangent, one period is going to be a pi distance. And so in order to graph this thing then, now that we have the vertical asymptotes, we're going to use some strategic values. Again, looking at your unit circle, some of the strategic values that we can use are negative pi over 4, 0, and pi over 4. And the reason that these are so strategic is because they give us really clean, easy numbers to use. And so I'm going to get for a negative pi over 4, tangent's going to be negative 1. At 0, tangent will be 0. And at pi over 4, it's going to be 1. So we're dealing with this middle section. So 0, 0 is right here. Let's call this 1, and we'll call this over here negative 1. So at this will be pi over 4 negative, and this will be positive pi over 4. So at negative pi over 4, we're going to get a negative 1. And at pi over 4, we're going to get 1. So now this graph is going to look like this. That's one graph of tangent. But notice that we have periods along the way, and so the values are just shifted over. So at pi, we're going to get 0. And then we can see that we just follow that same pattern. So at 3 pi over 4, we're going to get a negative 1. And then at 5 pi over 4, we're going to get 1. And then we follow again what the graph is going to look like. Same thing if we were to shift over to the other side. We're going to get the exact same picture. And that is what tangent of x looks like as a graph. Remember, the important piece to starting to graph this is to find the vertical asymptotes, and that's found again by remembering that tangent is a fraction of sine over cosine, and knowing where cosine is 0. Now, in the next example that I'm about to show you, we have an amplitude here of 2, and we have a shift here that shifts us down 1. So we're going to shift down. So in order to do this, again, it's still tangent, so we know we're going to have the same asymptotes as before. So the asymptotes are going to be at pi over 2, 3 pi over 2, negative pi over 2, and negative 3 pi over 2. So I wanted to get those so you guys can see them. So now that we have those values, I'm going to create a table for you to be able to see this. So bear with to my table. Here's going to be x. Here will be tan of x. This will be 2 tan of x. And then the last one will be our function f of x with the shift down. So again, being strategic, I'm going to use negative pi over 4, 0, and pi over 4. And so I know that tangent at negative pi over 4 is a negative 1. And if I multiply by 2, that's going to be a negative 2. And then if I take away the 1 from the function, I'm going to get negative 3. And again, it's taking away that minus 1 from 2 tan of x. And then at 0, I know that tangent is 0. 2 times 0 is still going to be 0. And then if I subtract 1, it's going to be a negative 1. At pi over 4, tangent is 1. Multiplied by 2, and then taking 1 away is going to give us 1. So now, let's go ahead and graph this. We see that at 0 for x, we're going to get a negative 1. At 1, we're going to get the point 1. And then at negative pi over 4, we're going to get a negative 3 value. So that was 1, 2, 3, so that's this value right here. So this value up here is pi over 4, 1, and our function is going to look like this. So we can see what's really happened is we multiply by 2 and then shift it down. So the origin, which would have been our original point, here actually just got dropped by 1 because multiplying by 2 times 0 is not going to do anything, but that vertical shift down drops it down 1. Now, if I go, the easiest way to graph the other points is just to move over pi. So pi values over to the right give us these values, and then we connect the dots. And then pi values over to the left. So we're going to be here, here, and here. And again, connecting the dots. There's our function for 2 tangent of x minus 1. Now, the domain for this problem is the same as the first, as tangent. We can see that the domain is all reals except for pi over 2 plus k pi, and where k is going to be odd values, right? So the domain ends up being all reals except pi over 2 plus or minus k pi. And the k is, 1, 2, 3, but we're not going to use 3. We're not going to use 2. It's always going to be odd values for that k. So we'd use 1, 3, 5, and so on from there. But a good way to figure it out simply is just look at the graph, and then you can see it's just actually, the k is 1, 2, 3, 4, 5. It's just adding them times pi. Okay, the next problem I want to show you is one that has an amplitude and also has a period change. So this is important because the period change, what it's going to do when it's a number bigger than 1, it's going to make the period shorter. If it's between 0 and 1, it's going to make the period larger. So we need to remember that tangent has a period, we'll call it t, of pi. So then the new period, when tangent is 2x, is going to just be that pi divided by 2. So now our period ends up being halved. And so to be able to do this, we need to remember where, again, cosine is 0, but it ends up being the half values. So I can draw, I'll draw some values for you to find it, and we'll do it that way. So if I use negative pi over 4, negative pi over 4 used to be a value of negative 1, but because we're going to be multiplying it by 2, it becomes negative pi over 2, and cosine of pi over 2 is 0. That makes the denominator 0, so this is undefined. So now I know that at pi over 4, I'm going to have a vertical asymptote. So I draw that vertical asymptote at pi over 4. At negative pi over 8, now that's being multiplied by 2. That becomes our new negative pi over 4, which would have been that negative 1, but notice that we need to multiply it by 3. So that negative 1 would now become a negative 3. I jumped the gun. I did the positive side instead of the negative side. My apologies. The vertical asymptote should be at negative pi over 4. 0 will still be 0. Pi over 8 will just be 3. And then pi over 4 positive is going to also end up being that undefined value. And again, that's because cosine of pi over 2, and I'll just show the math so you can see. Cosine of 2 times pi over 4 ends up being cosine of pi over 2. And if you look at the unit circle, that value is 0. And so tangent, again, is sine theta over cosine theta. And if cosine 0, that gives us that vertical asymptote. So just graphing this 1, it's going to be 1. Pi over 8 is halfway between. That's going to be 3. And then negative pi over 8 is going to be 1, 2, 1, 2, 3. And so when we graph this thing, it's going to look like this. You can see it's much more narrow. And then since pi over 2 is the new period, 3 pi over 2 is going to be a vertical asymptote. I'm sorry, not 3 pi over 2. 3 pi over 4 is going to be a vertical asymptote. And then so is 5 pi over 4 and 7 pi over 4. So you can see there's going to be a bunch of graphs for this one because the period has been shrunken so much. And all of them will have that same picture. Just repeated over and over again because we know that the periods end up giving the same values when you're exactly a period away. So here, here, and here, and we see that this is going to look like this. I'll just draw one more just to show you. And then once you have the first, you see that you can just generate the rest of them. And that's just going to keep repeating, looking like that within those areas. Notice the period again. That's one period. And that one period is pi over 2 distance. Okay. Let's go on to cotangent so you guys can see the difference between tangent and cotangent. Now, one thing we need to remember about cotangent is that cotangent is going to be cosine of x over sine of x. So now all of our vertical asymptotes are going to be where sine of x is 0. And so sine of x of 0 is at pi at 2 pi. Ooh, sorry about that. At negative pi and at negative 2 pi. And so we can see from here, cotangent has the same period as tangent. So the period for cotangent is going to be pi again. So when we go to plug in values, we can pick similar values as before. So I'm going to pick pi over 4, pi over 2, and 3 pi over 4. Just because 0 is also a vertical asymptote. Maybe I'll do that in a different color so you guys can see. Because the y-axis is also a vertical asymptote. So then at pi over 4, if I plug in pi over 4, the values of cosine and sine are the same, and so I'm going to get 1. So we'll get a value of, I'll call this 1. So this will be negative 1 down here. At pi over 2, it's going to be 0 because cosine of pi over 2 is 0. And then at 3 pi over 4, they're both going to have the same value except for different signs, and so it's going to be a negative. And so we get the negative 1. And look and see what it looks like. It's so interesting. Tangent and cotangent being reciprocals, we see that one goes from bottom side left up to the right, and now cotangent goes from top side on the left to the bottom side going to the right. And so we see these values are going to repeat. And you see cotangent with its period of, again, pi is going to be doing the exact same thing. Now, obviously, this is going to take some practice, so you're going to have to be able to do this math with using the unit circle, but it's always beneficial to write when you're doing tangent and cotangent as sine and cosine functions, and then plugging those values in to see if you can clean it up. Okay, so the next graph I want to show you is actually pretty cool. Now, these graphs actually, if you can graph sine and cosine, become very, very, very useful. So cosecant of x, we must remember, is the same as 1 over sine of x. And so what I'm going to do in this problem is I'm actually going to graph sine of x for you, and then go from there. So we know that sine of x is 0 at 0, at pi, at 2 pi, at negative pi, and at negative 2 pi. And we know that its values are 1 at negative 3 pi over 2. It's negative 1 at negative pi over 2, and then 1 again at pi over 2, and then negative at 3 pi over 2. And so I'm going to graph this for you, but I'm going to do it dotted so you guys can kind of see. So you should agree with me that this is the sine function. Now, for cosecant then, since it's 1 over sine, everywhere we see that sine is 0, we're going to have vertical asymptotes. So this is a vertical asymptote here. This one will be 1 at pi, so we just had that one at 2 pi. We can see it's going to be it's going to be a vertical at 0. And again at negative pi. And at negative 2 pi. Okay. Now, to graph it, what's interesting is when sine is 1, cosecant is going to be 1. So we can see that cosecant is going to also be that value. And what's going to actually happen is it's going to flip parabola. So if you thought of it as in those vertical asymptotes, the parabola of sine in that little picture would be flipped over. And so cosecant ends up being using the peak of sine as its highest or lowest value when graphing it. And so this is what cosecant looks like. It's the black parabola that you see there. And what's interesting about this is, again, it confirms we have a period of one period that is going to be pi in length. And so cosine was 2 pi, but because it's got 0 values that cause vertical asymptotes, cosecant has a period that is that's pi. Okay, let me go on to show you secant, and secant is much the same. So again, I'll graph it so you guys can see by graphing cosine and going from there. So we know that cosine's values are 1 at 0, 0 at pi over 2, negative 1. And so we'll follow that pattern and then draw just a dotted look at cosine. And so again, with cosine, what we see is similar thing, but again, we have zeros, and since secant, again, remember secant is 1 over cosine of x. Everywhere that cosine is 0, we're going to have verticals, and so everywhere we see it being 0, we need to put those verticals in. Okay, and then to graph it, just like cosecant, secant's going to use those peaks and troughs to be used to launch off of. But again, cosecant and secant, if you can graph cosine and sine, you can graph these two. That will make it very, very it'll be a very useful tool for you to be able to do these problems. Okay, I want to do one last example for you that has some manipulation to it. So let's get to it. So in this problem here, we see that we're going to have, again, an amplitude, and we're going to have a vertical shift. And that vertical shift is going to take us down a value. So in order to graph this problem, what we're going to have to do is do some cool calculations. So again, with cosecant, it's when sine is 0 that we have vertical asymptotes. And so remember, sine is 0 at pi. 2 pi negative pi and negative 2 pi. And then just so we can see it, use red for that, at 0. Okay. So we have those. Now, what's happening here is our values for sine, so sine at pi over 2 is originally 1. So remember that sine at pi over 2 would be equal to 1. But, so if we have that value, using that to do our math, we're going to get 2 times 1 over sine of pi over 2 minus 1. We know that's the same as 2 times 1 minus 1. So the shift of 2 would make it become a 2, but since we're taking a vertical, the amplitude of 2 is making us multiply by 2, which gets us 2. But then when we subtract 1, we end up right back at 1. So it's interesting that in this case, the subtraction of 1 is just going to make our picture look identical to the one that we did before. By that same reasoning, if we do 3 pi over 2, we know that sine of 3 pi over 2 is actually equal to a negative 1. So what ends up happening is 2 times 1 over the sine of 3 pi over 2 minus 1 is going to be negative 2 minus 1, because we can see that this parentheses is the same as that negative 1, and so we're going to get a negative 3 value. So well, bummer, it's going to be way down here. So that point's going to be way down here, and I'll actually do it in a bright color so you can see it. This guy's going to go down like this. So now that we see that, in order to graph the others, this one would go here and go this way, and then the other one on this side would just simply be up here like this. So even though our top values were the same as cosecant, our values below got shifted down by 2. So because what our original cosecant function would have been at this point here dropping down, right, going this way. But then we did a shift of 1 and then a shift of 2 down. So that's where we got that 3. And then here again, this is where we would have been, but there's 1 shift and there's 2 shifts down because of the vertical, because of the amplitude multiplying it. With these problems, it's going to take practice. Please feel free to shoot me an email, and I'll post it on our discussion board, a worked out example for you to look at. As always, all the best. Take care.